hello everyone. I hope you can hear me well. I'm Soline from WeLOOP, and today I'm going to introduce the different indicators that will be used in the Compass tool. So first, I will talk about the goals and about the planning and the actual state of progress of these indicators. And then I will describe more precisely the criticality and environmental indicators. And there will be a short introduction about the criticality tool. And finally, I will shortly talk about the drafting of the methodological guidelines. So first, the goal is to realize a multi-criteria and a multi-step analysis, and it is about data center equipment. So this analysis is based on the recycling process developed by T&D. And in order to achieve this goal, we must elaborate 4 indicators. These indicators are the following ones. So environmental, criticality, cost, and social indicators. Environmental indicators are calculated based on an environmental multi-criteria analysis using the EF method. Criticality indicators are calculated based on a criticality assessment method, like, for example, the GRI, so Global Resource Indicator method. Cost indicators come from a life cycle costing. And finally, social indicators are calculated based on UN environment guidelines and a stakeholder survey. So now I'm going to provide an update on the planning and the actual state of progress of these indicators. So the first stage is the dismantling and equipment characterization, and it was done for most of the items of equipment. However, there are still some characterization tests in progress. And then goal and scope were defined, and at the present time we are collecting data from stakeholders like T&D about the recycling process, for example, and we are also modeling. And the last 2 stages are the assessment of the impacts and benefits and the interpretation of the results to use in the Compass tool. And they haven't started yet, except for the criticality indicators. So here you can see the state of progress of each indicator. And as environmental and criticality indicators are the most advanced ones, I will present them with more details today. So criticality indicators, first of all, they are divided into 2 categories. So first of all, we decided to generate first-level criticality indicators based on the average ore content in the mine. And they are also based, of course, on the metal content in each piece of equipment. And then next level criticality indicators were generated using the GRI method. And they seem to be more precise than the first level ones because they are based on geological availability, geopolitical accessibility, recycling at the end of life, and also based on the metal content. And the metal content in percentages in each part of the equipment is multiplied by the equipment total weight. And in this way, we obtain absolute numbers. So in the end, we obtain short and long-term indicators in iron equivalent for Europe and for the world. And they allow the comparison of 2 servers with different weights and composition. Also, we created a criticality tool in order to assess the criticality of different types of equipment. In this tool, you can find a characterization table like this one. So this one is for a specific server. In the first line, it contains ID for part of the server. Then the first column shows us the list of metals included in the characterization test only. Here, they are metal contents in percentages, and they are multiplied by the server total weights to obtain absolute numbers. It is also important to note that for the weight percent calculation, the 100% reference here is the server total weights. And it's also important to note that here only the complex parts of the server were assessed in terms of criticality. So for example, here we have a CPU, so central processor unit, a RAM, and there are lots of PCBs. So only the parts of the server that were characterized. The criticality tool also allows to compare two servers. So for example, two specific servers with specific metal contents. And it also allows the comparison between a specific server and an adjustable one. So you are able to adjust metal contents in this table in order to create, for example, an average server that you would like to compare with the specific server. Here, short-term results for a Dell server from 2003 are presented in some graphs. It's just an example, so these results are not necessarily representative of more recent generations and more recent servers. This graph shows us short-term criticality per metal for each part of the server, and we can observe that there is a high criticality for indium in the CPU, and also high criticality for strontium and tantalum metals in the PCB motherboard, that is the main PCB of the server. Then here we have short-term criticality per item of equipment. And we notice that the main PCB motherboard, then the central processor unit, and finally a secondary PCB are considered as the hotspots of this server because they represent about 80% of the total criticality. Then this is the last graph, and it shows short-term criticality per metal for the entire server. And we have strontium, indium, and tantalum metals. They are the most critical metals, so the main contributors for criticality. Also, for HDD and SSD, even if the results are not definitive, it seems that the main contributors are gold, strontium, tantalum, and tin metals. And also, as Victor said earlier, there are less and even no rare earths in the SSD compared to the HDD because the permanent magnet was removed from SSD. Now let's talk about environmental indicators. So they are calculated based on the EF 3.0 method, which is recommended by the European Commission. And the modeling of the recycling process is done at the present time and on CIMAPRO. And it is based on generic data from EcoInvent and also on specific data from stakeholders. So at the present time, we are receiving data sheets from stakeholders like TND about the recycling process. And in this way, we obtain normalized, weighted, and single score results. So single score results, they allow the comparison between two types of equipment or between two products. So here, for example, you have a single score graph. And as you can see here, the product with the lowest single score is also the one with less environmental impact. And this kind of representation allows us to see the contribution of impact categories. So the impact categories are here. And for example, here, a hotspot for this product would be human toxicity, non-cancer, while for this product, we have climate change, particulate matter, etc. Now for the modeling, so we choose a functional unit, and that's the following. So it's one server used for storage and computing. And it is according to a specific use category, which means that they are groups of servers depending on their use category. And the lifespan is 4 years, with a life extension of 2 additional years in case of reuse. Here you can see the tree structure of the actual modeling on CIMA-Pro. So it's for a server, and we decided to model each part of the server independently. So here there is chassis, fan, CPU, etc. And also this modeling was based on the dismantling reports provided by stakeholders. Also, for complex items of equipment like PCB and CPU, RAMs, we decided to model based on specific results. So, for example, characterization results from stakeholders, instead of using generic data from the EcoInvent database. And in the end, results are presented in this form, so in a single score graph. So here, that's a single score graph for several types of PCB from the EcoInvent database. And as you can see, we can observe a hotspot. So that's the following impact category. So resource use for minerals and metals. And below the graph, we have all the impact categories from the EF method. So results of the environmental assessment will be presented in this form. And finally, CedaCI at the present time is drafting a document in order to harmonize the practice, to provide transparency and traceability, to guarantee the comparability of results, to provide the possibility to develop results for other servers in the future, and finally to provide default scenarios and assumptions. So this document is called a PCR. It is a product category rules, and to our knowledge, it's the first recognized PCR for data center equipment. So thank you for your attention, and if you have any questions, do not hesitate.